Hello everyone, it's Homer White back again with the first of another two-part series, this time on our second data analysis assignment. Again, in the first part, we'll just go over an example assignment and reiterate the basic structure that a data analysis report should have, but with emphasis this time on some of the differences between this assignment and the previous one. So first of all, how are you going to get to it? You'll want to go from your home directory to our common folder. So if you click on the ellipses in the Files pane, /MAT111, say OK, and you're in the common folder. It'll be under Dr. White Stuff if it's my course. And then find the specific course or section that you're involved in. And you'll see eventually Homework 02 example. There is a Markdown document and also a Word document. We'll focus on the Word document for this video lecture. And so you'll open it up. Remember, you may be able to download or it may pop up immediately, all depending on your computer system. And if nothing happens, remember to check for allowing pop-ups from RStudio on your browser. All right, here we go. Once again, you need a good title, your name, and an appropriate date. And there will be, again, 4 sections to your data analysis report. An introduction section, a methods section, which may be subdivided a little bit. In this case, it happens not to be. A results section, which is usually subdivided into descriptive results and inferential results. That's new for this assignment to have inferential results. Last time we looked at our question only from a descriptive point of view, but it's later in the course now and ready for more things. And then finally, your last section is a discussion and conclusion. So I'd like you to, before you go on with the video, to read the report through in its fullness, and then we'll have a more close discussion of it. All right, we're back again, and assuming that you've read through the report. As you've seen, the introduction to the report orients the reader to the research question that you have in mind, stated usually in a rather general way, maybe give some background about what might have led people to be interested in that kind of question. And also, since this is a data analysis report where you're handling data that's already been collected, you might talk a little bit about how the data was collected in the introduction. Later on in life, when you do your own experiments and studies and write a report on them, the talk about how you collected your data may go under methods. But for a data analysis report like this one, where you're handed the data, that kind of thing will belong in the introduction. So our question was whether people make choices rationally based only upon information that's relevant to the issue that they must decide, or is their decision affected in part by irrelevant information? Many psychologists today believe that we are often influenced in our decision-making by irrelevant information, and one way that this happens is through the anchoring effect. Notice there's a little introduction to the anchoring effect, even a link that in a Word document could be clicked for people to get more information about it. Also, some description of the survey in which this anchoring effect was studied. Remember, there were 2 survey forms that were given out to people. People didn't know that different folks were looking at different survey forms, but some folks were asked to estimate the population of Canada after having been told the population of Australia, which is a rather small number. Others were asked to estimate the population of Canada having been told the population of the United States, which is a rather large number. And if the anchoring effect is a real thing, then the folks who were anchored in the larger number, the United States, might very well give higher estimates for Canada on average than the folks who were anchored in Australia. So the specific form of our research question is, Do people give a higher estimate on average when they're anchored by a large number and when anchored by a small number? Okay, so the introduction has oriented people to the basic research question and the data that was collected to analyze it. So we're ready for methods. This time we're going to need to decide on inferential methods as well as descriptive methods, but the procedure always begins the same way. We identify the variables that are of interest in our research question, and we classify them, see whether they're factor variables or numerical variables, decide which one might be explanatory and which one is response, if that's appropriate for our research question. And of course, that's done after a study of the data set itself. Notice that the data set itself is not mentioned explicitly with our code here in this particular report, but we do tell the reader what the two major variables are. So the variable that records the subject's estimate of the population of Canada is the variable that's called in the data frame Canada. And then the variable that says which type of form the subject was actually looking at is called anchor. Canada is a numerical variable. It's some number of millions of people as an estimate. And anchor is a factor variable with possible values United States and Australia. We'll think of anchor as the explanatory variable, Canada as the response variable, because we're wondering if the anchor partially causes the estimate of Canada. By the way, notice since the forms were distributed randomly to the subjects, then the values of this explanatory variable were being assigned randomly to the subjects by researchers. Folks weren't coming to the study with those values already set. So we've got a randomized experiment here. We do not have an observational study. The key thing, though, is the nature of the variables. We've got a factor variable and a numerical response, so we can clearly do some graphical analysis with things like pairs of histograms or box plots or density curves that are broken down into the two groups according to the values of the factor variable US and Canada. Also, when we look at the question inferentially, we notice that the factor variable has two values. The response variable is numerical, so we could compare two means. We could be interested in the difference of two means in terms of parameters. As an inferential tool at this stage in the course, we can look at confidence intervals for the difference of two means. That's what we'll go with. So having decided on the methods and made it clear to the reader what we plan to do, then we carry out our results. The results section is typically going to be broken down into the descriptive results and the inferential results. Descriptive results are graphical and numerical, so we may very well have subsections to correspond to each one. As far as graphical descriptive results, we decided to pick two graphical approaches. We decided to do parallel box plots and group density curves. Again, you're careful to tell the reader what's coming. Don't just hit them over the head with lots of charts and graphs and numerical output. Tell them what you're going to make for them. First of all are the parallel box plots, where you break down the estimate of the population of Canada into the two groups in the experiment. And here's what we see. And then, of course, some discussion of what you're seeing in those two box plots and what it means for the research question. Particularly the medians are of importance here. The median for the United States group was higher than the median estimate of Canada for the Australia group. So it looks like that's an indication of an anchoring effect here. The larger population of the US is prompting people to give larger estimates for Canada. Again, an introduction to the fact that density plots are coming up, and then we have the density plots themselves. Notice the legend that's been provided so that you can identify which plot goes with which group. And then some discussion of what you're seeing in those density plots and how it relates to the research question and to answering it. On to the section on numerical descriptive results. Kind of looks like we applied fave stats, broke the Canada estimates down by the anchor groups. And if you were to compare, for example, means, then you see that the mean estimate for Canada from the United States group, 177 million, much higher than the mean estimate for the Australia anchor group. So all of these results are just descriptive, but we can also look at the question inferentially. Does the difference that we observe in our two groups in our study indicate that anchoring is really causing the estimate that people give, or could the results just be due to chance in the way the data was collected? Could it be that just by chance variation in the random assignment of forms to subjects, that folks who were going to give a high estimate for Canada in the first place just happened to be assigned to the U.S. group, and folks who were predisposed to give a low estimate for Canada just happened to be assigned mostly to the Australia group? If that were to happen just by chance, then the difference between the two groups' averages could be due to that and not due to the anchoring. So is it reasonable to believe this could have happened? So in order to investigate the question, it's time to define parameters and get the inferential procedure going. So it looks like we're letting mu1 be the mean estimate of the population of Canada given by all 89 subjects in the experiment if all 89 of them could have been given a form where the anchor was the United States, whereas in fact only a few of them were. Let mu2 be the mean estimate of the population of Canada given by all 89 subjects in the experiment if all 89 of them could have been given a form where the anchor was Australia. Again, that didn't happen, only some of them were. So we don't actually know mu1 and we don't actually know mu2. But if you think the anchor has no effect on the estimates, you would believe that mu1 and mu2 are the same. In order to see whether it's reasonable to believe they're the same, we'll make a 95% confidence interval for mu1 minus mu2. Here's the output for a confidence interval procedure. First a little bit of descriptive results, and then what we're mostly interested in, the inferential results. Notice that after appropriately introducing the results and then giving them, we have a discussion of the results in which we try to interpret for the reader every important element that's printed out in the results. We have a point estimate of mu1 minus mu2. That's the difference of the sample means for the two groups. We have a standard error for this estimate, and part of this paragraph addresses the significance of that standard error for the research question. Of course, we have our confidence interval, and so we interpret the confidence interval, but we also use the confidence interval to address the research question directly towards the end of the second paragraph of the discussion here. In the final section, discussion and conclusion, we draw our general conclusion that the anchoring effect does indeed appear to have been confirmed by this experiment, but this is also a good section to do such things as consider safety checks. What's the reliability of the inferential procedure that you used? This is also a good section to consider what's the applicability of your results. Are the results applicable just to the subjects that you studied, or are they applicable to some larger population? You can also discuss questions of causality versus association. Another thing you can do in this section perhaps is to consider other related research questions that you might like to collect data on, and so on. In this case, there were two items that I wanted to discuss. The safety check issue that is often done in the final section, even though it relates to material that you have seen in earlier sections, and also the question of applicability of the results to the larger population. Thank you for listening.